Hey guys, so I have been asked to show some examples of multiplying and dividing with rational numbers, specifically numbers with the decimals. Okay, so I'm looking here for those specifically that want to know where I'm at. I'm going to be looking at number 61. I'm going to look at number 70 and number 71. So I'll try to do those three as quick and efficient as possible. So number 61 is 1 1/10 times 6 and 78 hundredths. So it'd be good to know how to read your decimals, right? So 1 1/10 and 6 and 78 hundredths. So when I'm multiplying numbers, and whether they have decimals or not decimals, it's really very similar as far as how. But I just want to stop here, though, to just make sure when we do get our final answer, we have some sense of what the answer is, right? So I'm going to just put over here kind of what would be that approximate. If I look, I'm taking really my whole numbers, 1 times 6. So this number is going to be somewhere around 6, right? I know I'm taking 78 hundredths times that one. So this number might be somewhere between maybe 6, maybe 7-ish. So I'm going to say this number is approximately 7. We'll go there. Okay, so that's always good for me to do that, just so that way if I'm doing the math and making all of using the algorithm for multiplication, when I come up with my answer, if it's like 100 and something, I know I've done something wrong, right? So it's good to stop, pause, and make sure you can do some estimate first. So I'm going to line this up just like I would as if it was just whole numbers. And I do not need to line up the decimal point when I'm doing multiplication. But at the end, the decimal places will matter, right? So in this case, if I'm doing multiplication here, 1 times 8, I just multiply that using the standard algorithm. And then I do the same thing. Now I have a place value holder here, right? Place value holder, move over. Now do the 1 times all of that as well. And I'm ignoring the decimal in this case. It's still there. I'm going to come back to it. But in the standard algorithm, I'm ignoring it. Doing my addition, I get 8, 15, which means I carry a little 1 there. And then I get 13 plus 1, 14, carry another 1. And I get 7 here. So now I have this number 7458. But remember, I need to look and go, okay, is the answer 74.58? No. Is it 745.8? No. So how you determine it, we did some estimations, so you probably know where the decimal place goes. But if I look, there's how many digits behind the decimal place. There's 1, 2, 3. 3 digits that are on the right of the decimal place. They're behind the decimal place. Therefore, my answer has to have 1, 2, 3 digits behind the decimal place. So that's multiplying numbers with decimals. Okay, so there we go. On number 61, so that's the final answer there. So let's do number 70. Number 70 was a division problem. It's 9.4 divided by 0.2. So when I'm multiplying 9.4 divided by 0.2, or in this case, 9 and 4/10 divided by 2/10. So when I look at this and you're dividing decimals, it is looking at the standard algorithm is the way to go, but there's some little nuances you got to remember. So I'm doing the 0.2 into 9 and 4/10, correct? So here's the nuance. When you're dividing using the standard algorithm, the long division algorithm, you want to take this wherever you have a decimal in the divisor, you need to move it so it's no longer there. So it's just shifting the numbers. Really all it is multiplying both numbers by the same thing. So in this case, I'm multiplying by 10, if you will, which moves that decimal place once over. And I'm multiplying this number by 10. So what I do to one, I do to the other. And that's where I'm coming up with this now division problem of 2 into 94. So that's the one trick there when you think about division, is looking at that number, the number that's dividing into, that you're moving that decimal place so it doesn't exist. Another way to look at it, I just want to make sure you understand this concept, is division is really the same thing as a fraction bar, right? I can write this problem as 9.4 over zero point 0.2, right? And what I just did here is I multiplied by 10 over 10, which is, again, if you remember the whole thing, it's just a giant 1. So I multiplied by 10 over 10, and that's why all of a sudden now, yeah, I know you haven't seen that, sorry. I multiplied by 10 over 10, which is just a giant 1. And that's why this becomes 94 over 2, which is what I'm doing here, that division there. I think you can take it from there.